Hello students, in last two videos we have seen about the straight lines and the problems related to that. In today's session we speak about the planes. As like the straight lines are uniquely determined when it is passing through a point and parallel to a given vector. That is one of the case, and the second case was a straight line passing through 2 points. Only two cases straight line was determined. Whereas in planes, the plane is determined uniquely in 3 of the cases. So what are they? Let me see it. The first case is for a plane, perpendicular distance from the origin. Perpendicular distance from the origin is given. Then how do you find out the plane? The second one is plane passing through a point and perpendicular vector is given. Plane passing through a point and perpendicular vector to the plane is given. Next, the last case is the plane passing through 3 non-collinear points. So these are the 3 cases we define a plane. What do you mean by plane? The surface. The surface itself is nothing but a plane. Otherwise, if you take the top of the book itself is a plane. So for this plane we are finding the equations. Now 3 cases. The first one, suppose if you take origin is your place only. From origin, if the perpendicular distance is given, perpendicular distance from the plane to the origin, perpendicular distance is given. That is one of the case. Second case is if this plane is passing through any one of the points, and for this perpendicular vector, first one is perpendicular distance. Perpendicular distance is given. Now we are giving the perpendicular vector as well as the point. And the third case is 3 non-collinear, means not lying on the same line. 3 non-collinear points are given. Then how do you find the equation of a plane? Let me see one by one. So plane is uniquely determined. Plane is uniquely determined if first one is perpendicular distance from origin is given. Second one is plane passing through a point and perpendicular vector. Here perpendicular distance given. The third one is passing through 3 non-collinear points. So in these 3 cases we find the equation of a plane. Now let me see how the equation of the planes can be derived in the simplest manner. First one, the perpendicular distance, equation of a plane when perpendicular distance from origin is given. Equation of a plane when perpendicular distance from the origin is given. It is very simple. This is an origin and you have a plane and perpendicular distance. So perpendicular distance D is given. Now see how it is. It is the origin. So plane is like this. Now perpendicular distance from the origin to the plane is given. So when the perpendicular distance is given, how do you find out the equation of a plane? Now for that what we do is, so given D perpendicular distance from origin to plane. This is the first point. Next, let n cap, or you can take it as let n be the perpendicular vector. So when it is perpendicular, you have perpendicular vector also. Let n be the perpendicular vector to the plane. When vector is given and its magnitude is given, then a vector in the direction of the given vector A and having magnitude, a vector in the direction of A and having magnitude lambda is from the vectors. When I was teaching straight lines also, I have just taken the basic concepts. That is, when the vector is given and its magnitude is given, then if you wanted to find out a vector in the direction of A having magnitude lambda is nothing but lambda A cap. So you have to make use of that concept. This is the first point. It is the second point. Then third point is a unit vector in the direction of n and having magnitude or length or distance having magnitude d is in the direction of n. Since magnitude is given here, so you have to make use of this concept. Magnitude d is d into n cap. That is, suppose if you take it this as n, so ON is nothing but d into n cap. I hope this point is clear to everybody. This is the perpendicular vector and it is magnitude. Therefore, the ON is nothing but a vector in the direction of n having magnitude d is nothing but d into n cap. Next, fourth point. Let P be any point in the plane whose position vector is r. So I will take P be any point whose position vector with respect to origin is r. Then we know that this is, you can see dA, this is ON plus NP is equals to OP by using the triangle law of addition. Then in triangle ONP, ON plus NP is equals to OP, which implies NP is equals to OP minus ON. NP is equals to OP minus ON, whereas OP is equals to R minus ON. Already we have found ON is nothing but D into N cap. So I found what is Pn. Now the last point is, when you see the picture, Pn is perpendicular to ON or NP is perpendicular to ON. So in figure, in triangle ONP, this is ON is perpendicular to NP. When these two lines are perpendicular, their dot product is 0, which implies NP dot ON is equals to 0. So just to substitute this, NP is nothing but R minus D into N cap dot ON is equals to D into N cap is equals to 0. since this is a constant, d is a constant, you can send it that side, then it will become r minus dn dot n cap is equals to 0, which implies r minus, this is r dot n cap minus d into n cap dot n cap is equals to 0. Now, which implies r dot n cap minus d n cap dot n cap is magnitude of n cap is nothing but 1 minus d is equals to 0, which implies r dot n cap is equals to d, which is the equation of a line, which is the equation of a line when the perpendicular distance is given, when the perpendicular distance is given. So I hope this derivation is clear. I have not used any of the new concepts. Whatever we were having, the old concepts, same old concepts I have taken here. So this is in vector form. Now you have to go for Cartesian form. So how to find Cartesian form? Next, for the same thing, Cartesian form. Let r is equals to xi plus yj plus zk and n cap is equals to, this is a unit vector. N cap means it is a unit vector which will be having only direction cosines. This is li plus mj plus nk. Then star implies, you can make this as a star. Star implies xi plus yj plus zk dot li plus mj plus nk is equals to d. Do the dot product. This is lx plus my plus nz is equals to d, is nothing but equation of a plane in Cartesian form when the perpendicular distance is given. So this is about the first proof, but you have to go little bit slowly because you have to recall all basic concepts. The basic concepts you have to make use. Two basic concepts. A vector in the direction of a given vector and having the magnitude. Then when two vectors are perpendicular to each other, so automatically you will get the derivation of this plane. I hope this is clear to everybody. Next we move to the second one. Now let me come to the second concept, that is plane passing through a point and perpendicular to the vector. There is nothing is given from the origin, like the perpendicular distance is not given now. Now what is given? Plane is passing through a point A and perpendicular to the vector. So when you are doing the plane problems, you have to remember that we need a point and we need a perpendicular vector. Straight lines, we need a point and we need a parallel vector. And here in the planes, we need a point and we need a perpendicular vector. That much only you have to remember. Now how this derivation is done? So plane is passing through A of x1, y1, z1, whose position vector is A and perpendicular to the vector n. Let P of x, y, z be any point on the plane and whose position vector is r. Now, when 2 points are there, you can find the vector AP, that is the vector AP. How the vector AP? Previously points, now I am converting into vectors. Now vector AP is perpendicular to n. That's all only proof. When AP is perpendicular to n, the dot product is 0. That's all. Problem is over. So from figure, vector AP is perpendicular to n. When two vectors are perpendicular, their dot product is equals to 0. What is AP? AP is nothing but r minus a dot n is equals to 0. R dot n minus A dot n is equals to 0, which implies R dot n is equals to A dot n. Either you can use this or use this. Proofs are very simple. Perpendicular in straight lines, parallel, nothing else. But you have to trace what is the vector to perpendicular to which vector, that much only. In the Cartesian form, when you take it in a Cartesian form, let R is equals to, so you can make this one as star. So let R is equals to xi plus yj plus zk, comma, vector A is nothing but x1i plus y1j plus z1k, and n is equals to the drs. You can take the drs as a, b, c. So that is ai plus bj plus ck. Don't be in confusion. This is a vector, position vector, where it is a scalar. So these two are not same. It's a vector and here it is a scalar quantity. Now just apply star by putting in star. This is R minus A dot n is equals to 0. xi plus yj plus zk minus of x1i plus y1j plus z1k is equals to dot n is ai plus bj plus ck is equals to 0. Now simplify this. X minus x1 into I plus y minus y1 into j plus z minus z1 into k dot ai plus bj plus ck is equals to 0. Do the dot product, which implies a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equals to 0. So this is the equation of a plane when it is passing through a single point and perpendicular vector is given in vector form, and that is in Cartesian form. The next one is passing through three non-collinear points. There also we have to make use of same concept. Perpendicular vector you have to find it, and it is passing through 3 points are there. You can take any one of the point. Let me see this. Now let me see the third concept, that is plane passing through three non-collinear points. So now you can see here A, B, C. They are not lying on the same line. So I have taken care of here. A, B, C. Three non-collinear points I have taken. P of x, y, z be any point in the plane. Now plane means what is required? Passing through a point and perpendicular vector. These two only main important. Passing through a point. 3 points are there. I can take any point. So let me choose A. Perpendicular vector is not given. I have to trace the perpendicular vector. So how can I trace the perpendicular vector? From the 3 given points only. So the best way is make a vector AB, make a vector AC. Sir, why should we make AB AC? Why can't we make BC? That is up to you. So the easiest way is take a vector AB, take a vector AC. Then a vector which is perpendicular to both the vectors is nothing but a vector which is perpendicular to both the vectors is nothing but its cross product. So the perpendicular vector is nothing but, so in this plane you have two vectors AB, AC. So perpendicular to this is nothing but AB cross AC, which is nothing but the perpendicular vector. So I hope you have understood this. Perpendicular vector is not given, you have to trace the perpendicular vector. So how do you trace the perpendicular vector? From the given information, from the given 3 points, make 2 vectors A, B, A, C. Then we know that a vector which is perpendicular to both of the vectors is nothing but its cross product. So perpendicular vector I am taking. Now my job is over. Plane passing through a point and perpendicular vector. So straight away I can write the equation. So join AP from figure, or we can write it from figure. Perpendicular vector to the plane is n is equals to AB cross AC. Therefore, you can write it as, and AP is perpendicular to n. So this vector AP is perpendicular to n, which implies AP dot n is equals to 0. That is, AP is nothing but R minus A dot n is nothing but AB cross AC is equals to 0, which implies R minus A dot AB is nothing but B minus A cross AC is nothing but C minus A is equals to 0. This is vector form. So I am not doing anything new here. Whatever is there, just I am taking that sort only. So AP is OP minus OA or minus A. N is nothing but AB cross AC. AB is nothing but B minus A. AC is nothing but C minus A. Now how to do in the Cartesian form? So Cartesian form. In Cartesian form, this is nothing but dot product also is there, cross product also is there. When dot product is there, cross product is there, this is a scalar triple product which is nothing but a determinant. Scalar triple product is nothing but a determinant, but scalar triple product is removed from the syllabus. Even then I have taught to you. So scalar triple product, it is not there in the syllabus. Even then we have the idea. So what is that? Scalar triple product is nothing but a determinant. What is the determinant? That is, first one, R minus A. R minus A means x minus x1, y minus y1, z minus z1. B minus A, x2 minus x1, y2 minus y1, z2 minus z1. C minus A is x3 minus x1, y3 minus y1, z3 minus z1 is equals to 0. This is the easiest way. When you use scalar triple product as a determinant, this is the easiest way. All coordinates already we have written, so let me not write once again. So I hope these three are clear. One, perpendicular distance from the origin is given. Second, passing through a point and perpendicular vector is given. Third one, passing through 3 points is given. These are the major concepts. Now apart from this, we have some minor concepts. So let me see it. Next, fourth concept is general equation of a plane. What is the general equation of a plane? That is, in vector form, R dot n is equals to d. This is not the perpendicular distance. This is not the perpendicular distance. This is simply, it is given R dot perpendicular vector, d is nothing but a constant. R dot n is equals to d. Then in Cartesian form, this will be ax plus by plus dz plus d is equals to 0. D is a constant. If it comes minus d, or you can take it as plus d, it won't give any difference for us because it is just a constant only. Ax plus by plus cz, or you can take it as r dot n plus d is equals to 0. But let me follow the standard format, that is r dot n is equals to d, and here in Cartesian form ax plus by plus cz plus d is equals to 0. Next, fifth one, intercept form. So like your class 11, the intercept form of a straight line is x by a plus y by b is equals to 1. Here also the intercept form is x by a plus y by b plus z by c is equals to 1. There is no vector form here when the intercepts are given. So that will be x intercept is a, y intercept is b, z intercept is c, that is equals to 1. Next, sixth one, angle between two planes, that is vector form. Let two planes are r dot n1 is equals to d1 and r dot n2 is equals to d2, where n1 and n2 are perpendicular vectors. n1 and n2 are perpendicular vectors to the plane. Like a straight lines, when you found the angle between the two lines, we found the angle between two parallel vectors only. In the same way, whenever you are finding the angle between two planes, you will be finding the angle between two perpendicular vectors. What are they? n1 and n2. Therefore, cos theta is equals to n1 dot n2 by magnitude of n1 into magnitude of n2. Next, when you come to the Cartesian form, let the two planes are a1x plus b1y plus c1z plus d1 is equals to 0, and a2x plus b2y plus c2z plus d2 is equals to 0. These are the given two planes in which drs of the perpendicular vectors are a1 b1 c1 and a2 b2 c2. They are nothing but drs of the perpendicular vector or normal vector. Therefore, cos theta is equals to, in Cartesian form, a1 a2 plus b1 b2 plus c1 c2 by under root a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square. If two planes, note 1, if theta is equals to 90 degrees, that means two planes are perpendicular. Then n1 dot n2 is equals to 0. Am I right? Cos 90 is 0. Therefore, n1 dot n2 is equals to 0, or a1 a2 plus b1 b2 plus c1 c2 is equals to 0. So this is about angle between two planes. The next concept is seventh one is the plane passing through the intersection of two planes. How it is? Just you can see, this is a plane, this is another plane. It is a plane, this is another plane. So intersection of these two planes is nothing but a straight line. So you need a plane passing through intersection of these two planes. So passing through the line which is common to both the planes. So that is plane passing through intersection of two planes. Plane passing through intersection of two planes. First one, vector form. What is vector form? R dot n1 is equals to d1 and R dot n2 is equals to d2 or given planes. Then required plane is R dot n1 plus lambda n2 is equals to d1 plus lambda d2. That means you are joining both the equations by using scalar multiple. In Cartesian form, a1x plus b1y plus c1z plus d1 is equals to 0 and a2x plus b2y plus c2z plus d2 is equals to 0 are given planes. Then required equation of plane is, that means a plane passing through the intersection of these two planes is a1x plus b1y plus c1z plus d1 plus lambda times of a2x plus b2y plus c2z plus d2 is equals to 0. You are joining both the planes by using scalar multiple. So I hope this is clear. This is about plane passing through intersection of two planes. Still some more concepts are there. Next one is coplanarity of two lines. So what do you mean by coplanarity? Collinear points lying on the same line. Coplanarity, lines lying in the same plane. When do we say that two lines are lying in the same plane? Now just to see it, there are two lines in a space. If they wanted to lie in the plane, either they must intersect or they may be parallel here. That means the shortest distance between them, two lines are like this, two lines. The shortest distance between them, it must be equals to 0, then only they will lie in a plane. So I hope the concept is clear. There are two lines in a space. Now we are saying that these two lines must lie in a plane. When they wanted to lie in a plane, compulsorily the shortest distance between them must be equals to 0. That is the condition. So write down that 8.1. Coplanarity of two lines. Let R is equals to A1 plus lambda B1 and R is equals to A2 plus mu B2 or two given lines, not plane, or two given lines. They are the lines. Then these two lines are to lie in the single plane. What is the condition? That is condition for lines to lie in same plane. Condition for the lines to lie in a plane, or in other words you can use the word coplanar, is shortest distance D must be equals to 0. What is the shortest distance? So you know the shortest distance, that is A2 minus A1 dot B1 cross B2, am I right? By magnitude of B1 cross B2 is equals to 0. That is the shortest distance. So from this, when you multiply this will become simply A2 minus A1 dot B1 cross B2 is equals to 0. So this is the condition for the coplanarity of two lines. Next, ninth one, that is perpendicular distance from a point. You can take it as A of x1, y1, z1 whose position vector is A to the plane or dot n is equals to d or ax plus by plus cz plus d is equals to 0 is first one in vector form. So you can see here E of x1, y1, z1, and here you have your plane. Then perpendicular distance. This perpendicular distance you are finding. How do you find the perpendicular distance? This is very simple. That is, substitute the given point in the given plane. Substitute the given point in the given plane. That is the easiest way to remember. That is, suppose if it is vector form, in place, substitution means in place of xyz. Where is xyz? In the position vector. Substitute the given point whose position vector is A, that is A dot n minus d by magnitude of n. Since distance cannot be negative, you are taking as modulus. In Cartesian form, so what I have said, substitute x1, y1, z1 in place of xyz. That is a x1 plus b y1 plus c z1 plus d by under root of a square plus b square plus c square. Since the distance, you can put modulus. So that's all. Finding the perpendicular distance means just to substitute the values. That only you try to remember. Now we have come almost to end. Now only single concept is left over. So let me see that. Now let me see the last concept, that is angle between a line. Angle between a line and plane. When it is given line and plane, just we see here, this is a line. And plane means plane is here. We are considering the plane for this plane we are considering. This is the angle between the line as well as plane. Let the equation of the line is r is equals to a plus lambda b, and the general equation of a plane is r dot n cap is equals to d. Now, whenever we find the angle in straight lines, we are finding the angle between two parallel vectors. In the plane, angle between two perpendicular vectors. But here it is, one is parallel vector, another one is perpendicular vector. Therefore, whenever you find the angle between the line and plane, you have to find the angle between the parallel vector and perpendicular vector only. Perpendicular vector only. Parallel vector, perpendicular vector. So, parallel vector is B, perpendicular vector is N. Now, let me come to the angle. Let theta be angle between line and plane. but we don't want angle between plane. We need the angle between parallel vector, means so they will lie on the straight line only. So parallel vector, but perpendicular vector will not lie in the plane. Perpendicular vector will be just perpendicular to the plane. When you need the angle, you need the angle between parallel vector and perpendicular vector only. We don't want to the plane. So once again I repeat, angle between line and plane means that is angle between parallel vector and perpendicular vector only we have to find. But what angle is given for us? The angle is given, just angle between line and plane is given. We don't want line and plane. We want parallel vector and perpendicular vector. When it is perpendicular to the plane, if it is theta, automatically this angle will be 90 minus theta. So when you find the angle, you have to consider angle between parallel vector and perpendicular vector only. This is not at all required for us. Then 90 minus theta will be angle between parallel vector of a line and normal vector of a plane. Therefore, cos 90 minus theta, in place of theta, what angle is coming? 90 minus theta. Cos 90 minus theta is equals to, between parallel and normal, that is B dot n by magnitude of B into magnitude of n. But cos 90 minus theta is nothing but sin theta is equals to B dot n by magnitude of B into magnitude of. So I hope this is clear. With this I have covered all the concepts of a plane. So in the next video we will complete all the problems of